Factorenergia hoy es una compañía con más de 70.000 clientes, más de 220 empleados y más de 20 años de experiencia. El pasado año nuestra facturación estuvo próxima a los 400 millones de euros. Vemos que vamos a dejar de ser una compañía suministradora de energía. En este momento Factorenergia se dedica básicamente al suministro de electricidad, suministro de gas natural, a la prestación de servicios de representación en mercado a productores de energías renovables y cogeneradores, lo que se llama régimen especial, y una última área de negocio que en este momento estamos potenciando muy fuerte, le hemos llamado una área de eficiencia energética, pero sobre todo es una área donde vamos a impulsar el autoconsumo, donde vamos a impulsar la movilidad sostenible. En los próximos 20 años, pues lo que queremos promover es un mundo más limpio, sostenible, descentralizado e inclusivo. Un poco son los 4 pilares en los que se asienta nuestra visión de futuro. Al por qué Factorenergia está centrada en este tema, yo os diría que cuando se fundó Factorenergia hace 20 años, en la misión de la compañía se contemplaba la apuesta por las energías renovables, pero se apostaba sobre todo por la lucha contra el cambio climático. A mí me ha encantado que a nivel mundial empecemos a hablar de emergencia climática, porque el término cambio, pues claro, no tiene una connotación ni positiva ni negativa. Entonces hoy día estamos hablando de emergencia climática para entender que realmente tenemos un problema con el calentamiento global, no solo es una cuestión de cambio. Tengo el placer de presentaros a Ramez Naam.
I am at Singularity University, where we talk about using what we call exponential technologies, technologies that improve rapidly to address some of humanity's grand challenges. I'm also an investor in clean energy startups that are trying to be the next solar city, the next Tesla, maybe the next Factorenergia around the world. And this matters for a number of reasons. One, energy is a $6 trillion industry around the world. We have 1.3 billion people on planet Earth that don't have access to modern energy. And then the flip side is that the way that we produce energy today has massive consequences. The World Health Organization estimates that 6 million people die each year from air pollution. That is 10 times the death toll of all warfare and murder combined, and that is mostly from the burning of coal and gasoline. And then we have this problem, which is around the world, we see the planet is warming. And the planet's warming is not smooth, but you see as we zoom out, it gets hotter and hotter and hotter, and the 4 warmest years on planet Earth were the last 4 years. But the good news is the way that we generate energy is being disrupted. And I don't mean a small disruption, I mean a major change. And that major change is being driven by one thing, which is the plunging price of clean energy around the world. And so you see the cost of solar and wind are both just plunging at an incredible pace everywhere around the world. And before perhaps 2014, there was almost no place on Earth where clean energy was cheaper than fossil fuels without subsidy. And then suddenly in the last handful of years, that's become true, that in different parts of the world, including here in Spain, clean energy without subsidies has become competitive. So that means economic disruption. It means that you have to beat the price of fossil fuels. Now, in most parts of the world, you can build a new coal power plant or a new gas power plant for perhaps 6 US cents a kilowatt hour, maybe 5 euro cents. In Europe, that's not true. In Europe, it's substantially more expensive because gas prices are more expensive here. So perhaps it's 8 or 9 cents a kilowatt hour that you can generate natural gas electricity with here in Europe. And so what's happened over the last handful of years is that clean energy has gone from being much more expensive this to being substantially cheaper. Wind power. Wind power, we've had it for decades and decades. In the US, in 1980, wind power cost almost 60 cents a kilowatt hour, cost 10 times what building a new coal or natural gas plant cost. But because it was scaled, the price dropped tremendously, and now in the US we have wind power prices without subsidies of around 4 cents. And in other parts of the world, even cheaper. In Morocco, 2.8 cents, not that far from here really. In Brazil, 2 cents for wind power prices. If it has a competitive market where the cheapest energy wins, wind power can beat the cost of building new coal or new gas generation. And of course, that depends upon how windy your geography is. And there are these red areas on this map are the highest speed wind areas on planet Earth. And in fact, Spain has some excellent pockets of wind, especially in the south and in the north, where it's close to the sea. And so we've seen the price of wind power in Europe broadly, and in particular in Spain, just coming down. So we've had bids of 4.3 euro cents, $43 a megawatt hour, 4.3 euro cents a kilowatt hour in auctions in Spain. And these bids might have been cheaper. This was the floor price in these auctions. This is the lowest price to put forth. Without that, we might have seen even lower prices. Wind power around the world has scaled by a factor of 5 over the last decade, by 500%. It's growing extremely rapidly. And as it grows, the price comes down. Every doubling of the scale of wind power is associated with around a 20% reduction in price. And so that means we have this phenomenon that new technology in general, and wind power included, and solar and batteries, as I'll show later, starts off very expensive. But the first market, sometimes a subsidized market, means you get higher scale, and that means the price declines. And when the price declines, there are now new markets that it can go into. And now we're in the situation where wind power can scale into markets even without subsidies. So that means it will keep growing and keep going through this cycle, getting cheaper and cheaper. The other thing that's happening is we're building these larger and larger wind turbines, and we build these for economic reasons. The wind blows faster up high, it blows more steadily up high, and the amount of power you get from a wind turbine is equal to the area of the circle that it sweeps through. So if you double the length of a wind turbine blade, you get 4 times as much energy. That's why we're building these larger and larger wind turbines. And as a result of their size, we also get power that is more steady. People have long thought of wind power as very intermittent. You had to back it up with something else because it fluctuated so randomly, but that is less true all the time. We talk about capacity factor for an energy resource. 100% capacity factor means it's on all the time. We used to build wind turbines at a 10 or 15% capacity factor, but now at the best sites on land, we have wind farms being built with 50% capacity factor, and that's rising about 1% per year. Now, if you really wanted the fastest winds on Earth and the steadiest, you wouldn't stay on land. You would go offshore because the wind blows faster on the water than it does over land. But even 3 or 4 years ago, I would have said, and all the experts said, that offshore wind was too expensive and would never be cost effective because you had to have giant ships with cranes that went out to erect these. You had to anchor them to the bottom. You had salt water affecting your maintenance costs. And I'm one of the most optimistic people about clean energy, and I thought this would never be cost effective. But then in the summer of 2017, we had 3 bids in the North Sea in the German market where wind power developers just bid 0 subsidy. They would come in at wholesale market prices, and they didn't need any subsidy whatsoever. And since then, we've had half a dozen more in Germany, in Denmark, in the UK, and the price of offshore wind bids has shrunk by a factor of 3 in just a 7-year period. After traditional offshore wind, we will go to floating wind. We'll go to floating wind for a handful of reasons. One is there are parts of the world, including parts of the coast of Spain, where the seabed drops off too steeply for traditional offshore. And two, you can get floating wind out further away from the coast where the wind blows even faster, and that gives you positive economics. So this is the world's first really commercial floating wind project. This is off the coast of Scotland, the High Wind project, and it was expensive, but it produced a 65% capacity factor, especially in the winter, which is when you don't have much sun. And wind is also a winter peaking resource that I'll talk about. In Spain, you also have really quite good wind off the shore. Not the class 7 winds of the North Sea, but class 6 winds, which are extremely, extremely positive. And that's why you have a first offshore wind development, and why the first prototype, the first ever floating wind for Spain will be built this year. It's the Wind to Power prototype. It's actually 2 wind turbines on one floating platform, which allows you to save some of the costs, and I think this is still tiny, this will be a major factor in the future. So wind power is going to keep getting cheaper. Nothing of what I've showed you is an endpoint price. These are intermediate prices. The price of wind power will drop probably by half over the next 10-20 years, and the price of offshore wind could drop even more than that. Solar power makes wind power look slow and stagnant. The cost of solar power, the cost of solar panels in particular, has plunged in a completely extraordinary way. In 1977, 1 watt of solar panel cost you $77. Today, it's 22 cents. This is a 350 times price decline. This is physical infrastructure. This is energy. This is what we need for factories, to keep the lights on, to run data centers, for everything in our civilization. This is the master resource, and yet it's dropping in a way that no physical infrastructure has ever dropped. The cost of building buildings hasn't dropped like this. The cost of building roads hasn't dropped like this. This is almost like a digital pace of price decline in the most important physical commodity there is. And so now we have crossover, where in the sunniest parts of the world, solar power is just the cheapest energy you can buy without any subsidies, and getting cheaper the fastest. Again, we have to beat this number, 6 cents. In China this year, we've had the first unsubsidized solar farms being built, and they project the entire industry of solar to be unsubsidized by 2021. In India, another large rising country with large energy, growing rapidly energy demand, we've had solar bids at less than 4 cents a kilowatt hour, and even there where coal is cheap, that's remarkably cheaper than coal. And in fact, the price of solar in India has dropped by a factor of 4 in just 4 years. In the US, we now have bids that are 2 cents with subsidies. That's about 3 cents without subsidies. Half the price of new coal, 40% cheaper than new natural gas. The price of 20-year power purchase agreements, 20-year solar contracts in the US has dropped by a factor of 10. This is one of my favorite photos. In Abu Dhabi, one of the oil capitals of the world, I worked with the energy ministry there, and their math says every solar panel they deploy saves them money over what they're doing right now. And 2.4 cents, this was the record low price on Earth for about 13 months. In Chile, though, that got beaten at 2.15 cents, and Mexico down to 2 cents. So the same thing that we saw happening with the price of wind is happening with the price of solar, only faster. that solar prices started higher, and until about 2015 in most of the world, solar was only deployed if it was subsidized or mandated. And then suddenly, in just the last 4 years, the price of building new solar in sunny parts of the world has become cheaper than the price of building new coal or gas, and no one saw that coming. Now, of course, solar and wind both got their start here in Europe. Really, Germany started it all, and Spain and Italy played a big role also as early adopters. Now, Germany is less sunny than Canada, and the European subsidies and policies for renewable energy became very unpopular after a while as the subsidies started to be paid for by consumers. But they started that scaling, which brought down the prices for the world. And now those prices have come back to Europe. Germany last year saw bids as low as 4.3 euro cents for new solar, cheaper than new coal or new gas in Germany. The price of solar at German solar auctions dropped by a factor of half in just 2.5 years. And Spain, in renewables auctions that you had in 2017, saw bids also of 4.3 euro cents for solar. And again, this was a floor price. Developers were not allowed to bid lower than this. If they could have, they would have perhaps bid around 3 euro cents, 1/3 the cost of new gas generation in Spain, and perhaps cheaper than the cost of operating a gas plant in Spain. And you can see that because Germany had bids of 4.3 cents, and Spain has had bids of 4.3 cents, euro cents, and yet the least sunny parts of Spain are sunnier than the sunniest parts of Germany. So the natural price here is much, much lower. Now, driven first by policy and then by those economics, the scale of solar has exploded. 30 times growth in the last 10 years and 1,000 times growth over the last 20 years. Now, solar is still very small. It's smaller than wind. It's only 2% of world energy generation, but it is set to continue growing because now, around most of the world, in the areas that are about to get highlighted, new solar is cheaper than new fossil fuel generation if you can get a good cost of capital. And that means that now solar is almost unstoppable because it can compete in all of these parts of the world. So in Latin America, in the Middle East, in South Asia, in the southwest and west of the US, and potentially here in Spain, you're going to see solar keep getting deployed, and solar will drop in cost as it's deployed. And it drops in cost faster than wind. 30% price reduction per doubling, and it has 1.5 more doublings to go. So it will go through many, many iterations of this feedback loop of scaling, getting cheaper, and thus finding new markets it can scale into. And that means that in a neutral policy environment, just a policy environment where you can have long-term contracts and you have competition for new power, solar will eventually be cheaper than fossil fuels in almost the whole of the world, with the exception of the northernmost parts of Europe and a few other areas in the world. And in Spain, if at that price, at that pace of cost reduction, the future cost of solar in Spain could be as low as 2 euro cents, maybe as low as 1 euro cent in the next 10 or 20 years. And that's an incredibly disruptive price. Of course, the sun doesn't always shine and the wind doesn't always blow, right? And so the sun is only at daytime. If you see the sun at night, you should check with your doctor. Something has gone wrong. The wind is anytime, but the wind statistically is more at nighttime. And that means, and also across seasons, we have something very similar. This is data from the US, but it's very similar in Europe. The sun peaks in the summer, June, July, August, May. The wind is very low in the summer. The same is true in Europe. The wind peaks in the winter and spring when the sun is very low. So that means that even without energy storage, if you put solar and wind together over the size of a continent, you can bring in sun from the best areas, wind from the best areas, and you end up being able to produce perhaps 70% of electricity from just wind and solar and smart sort of dynamic control of those resources. And that means that for Europe, the least cost, highest renewables energy system isn't a number of energy islands, it's an energy continent, an energy EU, where wind comes in from the North Sea, hydro from the Nordics in the winter, solar, especially from Spain and from the south in the summer. And this is simplified, you get some wind from Spain as well too, but you integrate those resources into one European grid. That is the EC's vision, but of course there are many obstacles and the nations have to actually agree to make that happen. Now that might look like a lot of very long-range transmission, and perhaps you wonder if we can actually transmit power that far. We can. Here's what is happening in China. In China, all of the energy use is on the coast, but the best sun and the best wind are deep inland, deep to the west. And so China is building a ultra high voltage grid, has built. The longest of these lines is 3,400 kilometers long that brings in wind or solar power from Urumqi to the outskirts of Shanghai. It is 90% efficient and it adds perhaps 1 to 2 cents to the cost of that electricity. In Europe, a line like that would stretch from Sevilla to Copenhagen, right? And it would allow Spanish solar in summer and sometimes in winter to be powering Germany or the Nordics 2 hours after sunset. And that would be game-changing. And this is a vision that the issues are not economic or technological, the issues are entirely regulatory in making this sort of phenomenon happen. That said, eventually we have to solve this problem of energy storage. And energy storage is now the most exciting area in clean energy. It's still quite expensive, but it's dropping in price rapidly. You all know who this fellow is? Tony Stark? It's the closest thing we've got. The reason that Tesla has done so well with batteries is because lithium-ion batteries are also an exponential technologies. They've dropped in price almost by a factor of 9 between 2010 and 2018, which is just insane. And they will keep getting cheaper. That looks that batteries will get cheaper by a factor of 3 to 5 in the next decade. And that could see battery storage costing 3 to 5 cents a kilowatt hour, and combined with cheap solar, this would allow you to have, the day-night cycle taken care of at a cost lower than that of natural gas or coal or really almost any fossil resource. And that's just lithium-ion batteries. I'm an investor in clean energy startups, so I'll tell you that there are dozens, not just 10, but dozens of other battery technologies coming. Some for mobility that are lighter and smaller for the same amount of power, and some for stationary storage. This is massively disruptive to natural gas because solar plus a battery like this is, in the next 2 or 3 years cheaper than gas. So batteries will keep coming down. This transition has been incredibly confusing for the world's leading forecasters. We see at Singularity University, we see this graph a lot. We see that a new technology is introduced, and the new technology is at first inferior to the traditional technology. Solar at first is vastly inferior to coal or gas because it's so expensive. But if it's an exponential technology, if it's a rapidly improving technology, it gets better and better and better. And at first you don't notice that it's getting so much better. And then suddenly you have 2015 or 2017 here in Spain, and the new technology is better than the old technology. And then you're amazed at how fast it's come. And the forecasters miss the price decline. Here's US forecasts for the cost of solar power versus what actually happened, right? They forecast a slow decline, and what happens is an incredibly rapid decline. You know, the solar already cheaper than the 2015 forecasts, that were forecasts made in 2015 for what would solar cost, said in 2040 it would cost 15 cents a kilowatt hour in the US. And, you know, 3 years later, actually the next year, it's remarkably cheaper than that. Or here's the IEA's offshore wind forecast. The IEA in 2016 forecast that offshore wind would cost about 9 cents a kilowatt hour by 2040. Okay, a very long time. And what happened was the next year we had auction bids for 6 cents a kilowatt hour to be built in 2021. So it's just incredible. Or my favorite is this battery chart. Here's the US version of the IEA's forecast. Lithium-ion batteries would decline in price by about a third by 2048. And here's what actually happened, right? So the official forecasters, unfortunately, have a very, very poor track record, and there's no sign that they're really changing. So bet on the innovators and bet on this continual learning curve, this continual price decline, rather than on the forecasters. So these rapid price declines have now brought us to the moment of disruption. It is now upon us in the next few years. McKinsey put out this report earlier this year. They had this chart is when will wind or solar be cheaper than the existing gas or existing coal? And they said in Spain it would be around 2020 that you would have the cost of new solar or new wind be cheaper than operating gas or coal.
España es un país en que nos hemos pasado toda la vida diciendo que nuestro petróleo era el turismo porque carecemos de recursos energéticos. Somos un país en que el escaso recurso energético que tenemos, que es el carbón, tenemos un carbón que rinde el 50% a nivel térmico que el carbón centroeuropeo y que vale el doble extraerlo. Carecemos de petróleo, carecemos de gas natural, incluso carecemos de lo que está tan de moda del fracking, ¿no? de lo que sería el petróleo o el gas no convencionales. Factorenergia, hace escasamente 6 o 7 meses, firmamos un acuerdo de compraventa de energía, PPA, con un grupo que se llama Enol, un grupo español que se llama Enol, y que iba a construir 2 parques eólicos. Cuando hicimos la nota de prensa, nadie percibió que a lo que le dábamos más importancia a nosotros era que estos 2 parques eólicos no venían de la subasta. Es decir, no tienen ningún tipo de subsidio público. Y con el precio que ha ofertado Factorenergia, que es un precio razonable para estos 20 años y que se basa mucho en esta proyección de que la energía en el futuro va a ser más económica, los bancos habían dado financiación y estos parques ya están en periodo de construcción y estarán en funcionamiento en el año 2020. Solo haceros 2 reflexiones que nos queden como ideas muy claras. La primera es: las energías renovables no son más caras, sino que son más baratas. Es verdad que eran más caras, en este momento son más baratas y en el futuro van a ser todavía más baratas. Por tanto, en el futuro lo que vamos a tener es una energía abundante y barata para todos. Cuando hablamos de, alguien dice la movilidad eléctrica no va a ser sostenible porque es eléctrica, no, la movilidad eléctrica va a ser sostenible y además Ramez nos ha explicado toda la evolución de las baterías en que el coste se va reduciendo y hay nuevas tecnologías. Yo os diría que este cambio del que estamos hablando es inevitable. No estamos hablando de algo que puede suceder, es algo inevitable. Ya está sucediendo en el mundo y creemos que en España, que somos un país con las condiciones óptimas para la generación de la producción de energía renovable, ya os digo, por la diversidad de vientos y por el nivel de radiación solar, yo creo que tendríamos que estar de los primeros, tendríamos que estar al frente de esto. Y sobre todo, sin olvidar la necesidad de actuar contra esta emergencia climática que tenemos encima.